All right.
Okay. Should we go through it?
Yeah.
All right, let's learn about 7702.
Yeah. So this was I guess off the back of a couple of things. I guess started out checking out the Ithaca writings where they've been essentially throwing together some demos on off the back of their Odyssey testnet, basically to show off um EIP 7702, which basically lets you turn any EOA into smart contract of your choice. Um and that's also on their Odyssey testnet. So basically providing a couple of tools as well. So there's VM experimental support for this. It's available on testnet. So I thought it'd be fun to play around with that. Um, I thought the sort of best place to start was like within Scaffold ETH, like taking the Greeter contract and starting like rather than with the like what might actually be something useful to do with the like the dumb question of like what does this actually just mean when you're using this new functionality. So this is on Odyssey. This is like a burner wallet attached to nothing. One of the cool things on Odyssey is that all the EIP 7702 transactions can be sponsored by the sequencer, so you don't need any gas. Um, and so this is just a super simple like greeter contract, which basically is that working? Yeah. Which basically lets you set a greeting, if this works. Yeah, like set the greeting for a the the classic your contract that's in Scaffold ETH. So that's obviously not something you'd normally do with 7702, but I thought it'd be good to see what actually happens under the hood. So this is my burner EOA. This is a greeter contract, and when you call 702, like you basically just sign a message saying, hey, I want this code to be referenced or called when my now new smart account is called. So
So not
I
a
call
transaction, just a signed message. You're just signing a message saying, "Hey, I want this contract to be me."
so it's not a so it's a specific like there's actually a VM experimental thing to sign author. It's called like an authorization, and you basically pass that as a like new data field to a new type of transaction. So it is a regular transaction, but that's basically passed and read before the transaction is executed, and then like in this case, what happens is like I sign that message and then I sign the transaction, and so it immediately uh, calls my contract and sets hello world as the like the initial greeting. So yeah, so you've got this transaction here where I basically did that. I think there's
So
a thing
wait,
around.
so that was a single transaction. Okay, so it's a new transaction type. You signed that new transaction type, you submitted it, and at the same, like in one go, it turned your EOA into the greeter contract and set the greeting all in one atomic transaction. There wasn't like a transaction to turn it into a contract and then another transaction to interface with it. Am I saying that right?
Yeah, yes, yeah. So basically the setting of the EOA code is like happens kind of before the transaction. It's like like a separate little piece. So you can see this is like a transaction type 4. I don't know if it's actually got the other stuff. There's this thing where the block explorers can be a bit like confused by exactly by what's going on, like in some of these transactions at the moment. But that's kind of what happened. And if you like look at so these little pieces I pulled out to kind of show what's happening, like you can see that this account is now like pointing to the code. So this is basically that like should identify, and then you can see that the 5672, which is this 5672, it's basically the code is now pointing at that contract code, the greeter contract. Um, and so that's the first thing. And then the second thing that's happening is that we're also actually starting to store data in our EOA. So like in the first slot is the greeting. So that's a string. And then this is the like account, it's basically a counter. So this is one where like I can call it again and I can say, hey, and in this case, I don't actually need to set the contract again. I can just call call the function as if it is a as if it is a smart contract.
Yeah, so what does this look like? When you said hey right there, you're making a transaction. And normally when you're calling a function on a smart contract, the to address is a smart contract, and then the function selector is the function you're calling. Who is the to address here, and what is the function selector? How does that work?
Yeah, so the to address is just the EOA and the function
Okay.
selector is the classic
Okay.
greeting
Okay.
call.
So
So
we're
we can
calling it just like we're talking to it like it's a contract.
yeah, pretty much. So like if
Okay.
we look at this, we look at this guy. I don't know if this will show because this guy makes a lot of transactions, this being the sequencer. Maybe not. But but yes, it basically calls. And you can, I mean, you can see it's emitting logs. Like it's basically behaving like a contract, like a contract. So yeah, this is my 01EF. 01EF is like emitting logs and like it's
Wow.
having its state updated. So it's a whole thing, and like there's some gotchas there. So like if your contract doesn't have a receive function, then suddenly it can't actually receive like ETH anymore. So like as you start to play around, you see some of the kind of potential foot guns or things that you need to think about when you're like using this.
So the first one, really important there, an EOA stops acting like an EOA. You upgrade it to a contract, you've got to have that receive function, or you're not going to receive any money. And then you also mentioned another foot gun that has to do with storage slots while we weren't recording, but maybe you could talk through that here. If we were to downgrade and then upgrade again, these storage slots might still be set. Is that right?
Yeah, so I think this like I basically encountered this well. So I'd done this demo, which is basically like turning my burner account into a greeter, and then I was like, okay, let's actually use something that's going to be a bit more useful. So like a more multi-sig thing. So then if we jump across here to batches, the idea here was that it was going to let you like batch mint um ERC20s, and so I got that all set up, and basically it was like the initial transaction was failing, but it's basically because this like batch used like a multi-sig which had the nonce of the nonce in the first storage slot, which basically was it like you'd kind of expect it to be zero and the contract's initialized, but actually because I'd previously used my burner for this dumb greeter demo, like it was like initialized to this, and so like the zero that I was passing in was like was erroring out, and the signature was invalid. So it's that thing where suddenly you've got to like if you're actually going to be changing the contract that you reference from your EOA, then you might like accidentally, and like unless you think about that upgrade path, you might end up in some weird states. Hmm.
Can we
Um,
do it? Can we do the revoke and look at it?
so actually, yeah, that was the last thing that I added this thing to let you revoke. So see if that works. Yeah, so there it goes. So in this
And
case,
now we could send money back to the EOA if we wanted to. Like we
yeah,
could
so
send ETH and it would work normally.
this is now just a regular EOA, except it's got some stuff in storage basically, and it's emitted some logs in the past. Um, So yeah, so in this case, if I'd revoked, the challenge would be that if I then tried to turn this into a general like multi-sig um type 7702 path, which maybe a bit more makes a bit more sense than the greeter, um, you need to handle like what slots, like what the information was in the different slots. Um, so yeah, and yeah, I guess to jump to that, this is more just like a demo which kind of demonstrates the like it was I guess a couple of things. So first it's the like approve the
So these
approve.
are all burner wallets you just created, just randomly generated EOAs.
Yeah, so if I create
Okay.
these EUAs, then I can essentially drop. And so when I drop, that does a few things. Firstly, it initializes to this general sort of multi-send type contract. It calls a faucet to get some ETH. It calls a free token thing, and then it buys some buyable tokens with free tokens. So that's like you've got to have an
Wow.
allowance.
With
It's kind
approval, you mean you have to do the approve to go from one token to another token. There's an approve and a swap that has to happen. And you're doing all of that in one transaction, setting the 772, getting an ETH balance, getting free tokens, approving the free tokens to swap to buyable tokens, and then swapping the free tokens to buyable tokens.
yeah,
Sick. That's pretty rad.
yeah, and it's one transaction. So if we drop these guys, um, and then like similarly the kind of cool use case here again takes a little while, and Rockspro is not super happy with it necessarily. But then you could also just like move these, and so we're going to move everything to this contract. So again, you can just do stuff in single transactions um, that you'd have to do in multiple transactions conventionally with an EOA.
Very cool. Okay, so let's go. Let's get back to foot guns just for a second. There's the gotcha about not being able to receive funds. Your EOA basically turns into a contract, and if that contract can't receive funds, you can't receive funds. There's the storage slot thing where when you upgrade to one contract and you do some stuff and it saves some stuff, that stuff is going to be saved there even when you downgrade and then you upgrade to another contract. So you need to be thinking about your storage slots, and you need to go back to the, upgradability pattern and think about, you could be upgrading to a multi-sig and storage slots might already be set. You may need to actually like upgrade to some middle account that clears your storage slots and then upgrade to the multi-sig to be safe or something like that. And then you said something about it's never been easier to sweep an EOA, which I think is true here. Is like you hit one button here and it could sweep your entire account. It could approve and transfer all your shit somewhere else with one little click.
Yeah. I think I guess that's what this like
That
moving
proves that there.
demonstration is kind of showing.
Yep.
Um,
And
and,
then there's a final thing, and that's that the private key is always in the wild. Even if you upgrade some EOA to a smart contract, and that smart contract is this beautiful, immutable, hard thing, that private key could always get leaked at any point, and everything can get destroyed in that. Whatever's behind that address is can always be destroyed by that PK. There's no way to set it as an immutable contract that can't be destroyed. The PK always has the power to override it. Is that right?
yeah, I think it's basically this interesting thing where like it just changes some of the core like assumptions about what what a EOA is and what a smart contract is. Yeah, suddenly, yeah. The weird thing through developing this, I think I mentioned, was the like in like I'm using Cursor for development, and like it kept like saying addresses can't sign their own like you're using address this like as the signer, that's not possible. So like smart contracts can sign things suddenly. But also smart contracts can, yeah, as you say, you can never actually like definitely throw away the keys to these things. Um, and so, yeah, it changes some like ways of thinking about things, assumptions, as well as some of these foot guns, which again might not be a problem if you were sort of thoughtful and people don't necessarily like jump between implementations loads, but um, anything can happen, right? And like I say, I think the thing around it being as easy to sweep anything, like that's always the like the two sides of usability and
Good
security.
UX.
It's
Yep.
like how do you have both?
When the burner wallet got hijacked at ETH Denver, they were I the way that I talked about it was they used the beautiful UX. They grabbed the burner wallet off the table and used the beautifully smooth UX to send all the money to themselves.
Yeah,
That is the
exactly.
double-sided piece of good UX. Yeah, this is the smart contract signature thing is a really interesting thing too. If we have a smart contract and it needs to produce a signature to prove to someone that we are someone because they're just expecting it to be an EOA, how cool is that if you could like drop down to EOA mode, make a quick signature, and then drop back up to smart contract mode or load back up to smart contract? But that has all sorts of other security scary things. So
Yeah,
let's see, where can people go to like play with this code? Do you have first of all, go ahead and show something if you're going to show something there, and then let's talk about where folks can go to fork your code.
yeah. I mean, this was pretty much just the like, yeah, you're checking that the signer has addressed this, which is this like slightly weird pattern that you don't get in smart contracts until
Super weird.
like
Yeah.
until now. Um, anyway, let's see. So in terms of where this is, so this is the demo is live at 7702 greeter.basel.app. And then the code I think is linked at the well, and then here and then maybe in the footer as well, if I make that visible.
Okay.
Uh,
7720 in your GitHub though. I bet I can find that pretty easy.
yeah, so
Awesome.
and that's got some notes about the things that are happening and um yeah, some links to some of the other stuff that we use. So yeah, as I said, sort of big shout out to um the folks at VM and like Ithaca as well, who basically put the cool tools together. There's some limitations that you can't do it with like a MetaMask um, EOA at the moment, and like obviously some of the like other tooling all needs to change for everything to play nicely together. But it's pretty cool to basically have it so usable while it's still in such an early stage.
Heck yeah, dude. Thank you. I'm gonna share this with Build Guild